Okay, today we're looking at 10.1 Pythagorean theorem. And Pythagorean theorem is used when you want to find one of the sides of a right triangle. And if you look at a right triangle, you have two legs, here and here, and you have a hypotenuse. The hypotenuse is always the longest leg, or it's also going to be across from the right angle. Notice how it's directly across from the right angle. The other two are called legs, and they're basically interchangeable. It doesn't matter which one you plug in because it won't make a difference. It's a commutative property. So our formula for Pythagorean theorem is a squared plus b squared equals c squared. And a and b are the legs. Again, they're interchangeable. Doesn't matter which one's a or b. But c matters. C is your hypotenuse. It has to be your hypotenuse or it's not going to work. You're going to get the wrong answer. So c is always the longest one, your hypotenuse, the one across from the right angle. And you plug into this formula when you want to find one of the sides of a right triangle. So let's look at this. These are numbers 1, 7, and 11 from your workbook. If you look at the first one, it says A, B, and C. C is missing, so you're looking for your hypotenuse. If we plug these in to a squared plus b squared equals c squared, you have 9 squared plus 12 squared equals c squared. So let's solve that. 9 squared is 81, 12 squared is 144, and it equals c squared. Add these two together, and we get 225 equals c squared. Now, in order to solve this, I have to do the opposite of c squared. And the opposite of squaring something is taking the square root. So I take the square root of both sides. That'll cancel out the square and leave me with c equals 15. So my answer, my missing side of my hypotenuse, is 15. Try doing number 7 and 11. Okay, so go ahead and check your answers, and you end up with c equals 29 for the first one, and c equals 2 for the second one. Now if you look in the box here, the what if, this one ends up giving you 1, then when you take the square root, it's not a perfect square, right? If it's not a perfect square, then what you're going to do is you're going to either break it down, if it can be broken down, or you leave it as whatever the radical is. So in this case, c would be radical 13, and that's okay. It doesn't have to be a perfect square. Okay, so let's look at some of these word problems. A quilter is cutting along the diagonal of a rectangular piece of fabric, 3/4 yard wide by 1 yard long. What will be the length of the cut? Well, the first thing we want to do is make a square because we want to kind of draw it out. It's easier if you can see it. And, well, it's not a square, it's a rectangle. So actually, let me fix that. So we make our rectangle. And he's cutting along the diagonal of the rectangle. So here's our diagonal. And the fabric is 3/4 wide by 1. What will be the length of the cut? So what we're looking for is here, the C. Right? If you look at this like a right triangle, because it's a rectangle, it's half the rectangle, which makes it into a right triangle. So then we just plug it in. 3/4 squared plus 1 squared equals c squared. So that's going to give us 9/16. Plus, I'm going to change this to 16/16 because 1 squared is 1, but since we want to add these together, so that's going to give us 25/16 equals c squared. And if you take the square root of that, they're both perfect squares, so you end up with c equals 5/4. Or since you're talking about material, it would make more sense to change it into a mixed number. I don't usually want you to change it into a mixed number, but in this case it makes more sense to say 1¼ yards instead of 5/4 yards. Look at the next problem. See if you can draw a diagram and try to figure it out yourself. Okay, so in this one we draw a little diagram. It says a pilot flies south and then 600 miles west. So you see this one is 600, but the south they didn't give us. Where she lands the plane. How far south did she fly? So you're looking for this one. If the plane she lands is 610 miles from her starting point. So from here to here is 610 miles. So there's our triangle, right? We have our right angle here, our hypotenuse is here, and then we're missing, in this case, the A. Up until now, we've been missing the C. It doesn't really matter which one you're missing, but that's going to be your variable, is one of your legs. So when we plug it in, they're pretty big numbers, but I mean, they kind of have roots that are perfect squares. So 600 squared, 610 squared, and you end up with A squared equals 12,100, which gives you 110 miles. It's how far she flew south. So the converse of the Pythagorean theorem is trying to figure out if these side lengths would be a right triangle or not. So you would have to take the side lengths that you're given and plug them into Pythagorean theorem. Obviously, my C is going to be my longest side because it's the hypotenuse. So I plug these in. 16 squared plus 30 squared equals 34 squared. And then I solve it. So I get 256 plus 900 equals 1,156. Add these two together, and they do add up to equal the same thing. Since they equal the same thing, then yes, this is a right triangle. Okay, go ahead and try this one over here. So go ahead and check your answer. You'll end up seeing that you get 1,440 equals 1,369. They do not equal each other. So that means that these cannot be the side lengths of a right triangle. So it could be a triangle, but it's not going to be a right triangle because it doesn't work in Pythagorean theorem. So let's talk about Pythagorean triples. And basically a triple is numbers that work in Pythagorean theorem. They'll give you all perfect squares, right? So it works perfectly. It's called a Pythagorean triple. And there are lots of numbers that are derived from triples. So for example, 3, 4, 5 is a triple, but then other ones from 3, 4, 5 would be a triple. So for example, if you multiply 3 by 2, you get 6. If you multiply 4 by 2, you get 8. 5 by 2, you get 10. Then you can multiply that by 2. So you would get 12, 16, 20. That's a Pythagorean triple. So any of the triples, then their multiples will also be triples. So some common ones are like 3, 4, 5, 7, 24, 25, 10, 24, 26, and then the derivatives of 3, 4, 5, right? Definitely those are going to work. These are the ones that you're going to see the most often. So if you look at this one down here, 70, 240, 250, if you knock off the zeros, it goes right back to 7, 24, 25, which is one of our original triples. So if you memorize these, obviously you can plug into Pythagorean theorem and you'll always be able to tell if it works. But if you memorize the triples, it kind of saves you some times. And a lot of times you'll see something like this, and it's going to be like 3, 5, and this is a question mark. What's the side? Well, you know that if the hypotenuse is 5, which is the longest side, this is going to be a triple, a 3, 4, 5 triple. So you know that missing side is 4, and you don't even have to plug it into Pythagorean theorem. It just saves you a little bit of time. Okay, let's look at this one. A landscaper attaches a guy wire 10 feet up the trunk of a newly planted sapling. He stakes the wire between 24 feet from the tree. Well, I think it would be from 24 feet, or 24 feet from the tree. I don't know if we need the between. What could be the length of the guy wire if it forms a right triangle with the tree? Well, since it's 10 feet up the trunk, we already have the 10 there, and then the wire is 24 feet from the tree, it would be down here, and then we're missing our C. So we just plug it in to Pythagorean theorem. So we have 10. I don't know why my pen isn't working very well. And then we solve it. And this tells us that C is 26. And actually, this is a triple. If you go back and look, we have 10, 24, 26 right there. If I had memorized it, I wouldn't even have had to plug it in. I would already have known that that was a triple. Try doing the next one. Okay, so on the next one, they give you the area of a square, which is 625. So you have to plug that into here, which is the area formula for a square, side squared. And since they give you 625, you just plug that in, take the square root, and that gives you each side. So you know now each side is 25. If you did your diagram, it'd be easier for you to visualize it. So you're missing your hypotenuse. So if you take those two and plug it into Pythagorean theorem, you end up getting 1,250. And the square root of 1,250. Well, that can be broken down. We're not going to round it to the nearest tenth because we won't have calculators, but we can definitely break that down. So I broke it down over here, and we just did 625 plus 625, so we know that 2 times 625 is going to give us 1,250. 625 is a perfect square, 25 times 25, so I don't even have to keep going because there's a pair already. I can take one of those out. So I have a pair of 25, that comes out, and the 2 stays on the inside. So my answer is 25 square root 2. And since it's not a perfect square, I'm just going to go ahead and leave it like that as a radical. That's okay.